So again, I'm using this as an example to show how the central nervous system decode the information. So again, in this case, there's a pin that touch our skin. So obviously the B cells or the receptor is the one that just next to pin. So it will has the biggest response to the pin. And obviously A and C will also receive response and stimuli, and they will respond, but in a smaller manner. This is what I mentioned to you, right? That it's decoded by the frequency. So this was synapse to secondary neurons, but then the secondary neuron will send out synapse to the surrounding neighbor, in this case A and C. And in this case, this is not an excitation synapse, rather they are inhibitory. Thereby, they inhibit the transduction of A and C, and while still maintain the B signal. So to put it in a different way to the right is on the primary neurons, as mentioned, the stimuli B has the highest response and C is slightly lower, and then subsequently the side doesn't respond. But after processing by secondary neurons onto the tertiary neurons, what you can see now is the stimulus to B is enhanced, while A and C now is decreased. And that can explain why when we look at the picture that I showed you previously, when you look at the age, the transition side, that has the strongest contrast. While on just next to the transition zone, the color actually seemed to be dimmer. And again, if the color was actually uniform across different areas. So this is basically an illusion our visual system play on us.